Okay, got the Heathkit SB-200, aka I call her my ugly Betty because she was very ugly, and I cleaned it up best I could. But she might not be ugly no more, but she not pretty. But anyway, I'm done with the ugly Betty. So this is my my voltage power up. Not gonna key it down. Don't even have the tubes in it. But we gotta power it up on the Variac and do my voltage testing to see the voltage, if the voltages are good. We didn't do the low voltage safe testing only on this amp because this amp uses the negative bias, a negative 120 volts, to run the low voltage for the relays and all that. So I've got a variable high voltage power supply somewhere, but I didn't feel like digging it out and hooking it up just to test the low voltage. What did I decided to do is just put it on the Variac, no tubes again, and run the Variac up, and then if the high voltage is good, test the low. Just put a foot switch on it, which I did, and test the low voltage that way. It's not, 1000% safe like the amps with the 15 volt or whatever low voltage relays or low voltage circuitry. However, it is what it is. We feel fairly safe, and anytime you're running an amp live, that's what you're doing anyway. I'll talk more about that circuitry and stuff later on a long talk through on this amp. We'll show this right quick before I do it. This is the terminal strip where the 110 220 comes into. And if you see the wire jumper here and another one here, if you start at the top, these are just hold down screws to hold the bracket, so they don't count. So these 4 screws or terminal here are your actual terminals. And for 110, there's a jumper between this one and this one, and this one and that one. Okay, so you got 2 jumpers for 110. And on the Heathkits, if you go from 110 to 220, you only use 1 jumper, and it's on 2 and 3. So instead of having a jumper here and a jumper here for 110, for 220, you use one of the jumpers from here to here, and that's it. That's your conversion from 110 to 220 on Heathkits, at least the ones that I know of. So we just wanted to show that. They had people ask about that, and since I'm on a Heathkit run, this one's been recapped. More recap the air and cap in there, cleaned up best I could. This is ugly Betty, and this is the top side. Those new caps are much smaller, and they're actually more powerful than the old caps. Redid the heavy duty bleeder resistor Kluge that this amplifier had before, and it was already monobanded in the back. We just cleaned it up a little bit, and in the front it had the band switch and all the ham band stuff, even though the band switch was smoked, and there was some other bad stuff going on. So we took all the band switch and ham bands out except 10 meters, and this one has been monobanded, and it will work on 10 meters, 12 meters, and you could even tune it for 15 meters. It'll work on those bands, 10, 12, and 15, anything in between that. But anyway, we call that monobanded. It only has 1 band coil, taps for 1 band, no band switch to switch the band. Actually, there's just a screw in there holding the knob on it, and that's what I mean by monobanded. Even though it will work on actually 4 bands, 10, 11, 12, and 15 meters. But again, 1 band coiled, no band switches, band taps, and all that. And that's what I mean by monoband, since I had people say, what do you mean, you know, you monobanded, it work on 10 meters, 12 meters. Yeah, okay, whatever. But anyway, I didn't want to talk about this one too much. I just wanted to show it my power up. So it's on the Variac, plugged in. We're gonna make sure the Variac's down, turn the Variac off. We got the amp on, and we're gonna slowly ramp up the voltage, and we're gonna use the internal amps voltmeter here. We got it on high voltage, and for every 1 volt we put in on the Variac, it should show 20 volts on the high voltage meter, because this amp runs on 2400 volts DC. So, you know, 110 in or 120 in, 2400 volt, that's 20 to 1 if my math is working. This is early in the morning for me. So anyway, we're gonna run the Variac up. We got the Variac turned up a little bit. You can see the voltmeter going, and the voltmeter on the Variac, you know, very low. You can see it. We're gonna turn it down and turn it up. I guess you can see that movement, right? And over here with the watt meter, inline watt meter, we put this in line so we can see the amps that this thing is drawing. So we got about 25 volts going in it, and we're actually pulling 6 watts. This over here is the line voltage going into the Variac, and this is over here, we got it set on the watts going into the Variac, which goes into the amp. So, you know, 6 watts is nothing, so 25 volts, that's about right. So we're gonna dial up the Variac, let's say slowly to 50 volts, and now we're pulling about 10 watts, which is good. And over here on the high voltage voltmeter, we're up to about 400 volts. No, about 325, something like that. So anyway, everything's pretty good. No snaps and fusses and pops, or not pulling crazy amps or watts yet, and we shouldn't. You know, if the transformer and all the power supply is good, shouldn't pull much, because we're running volts, but it's nothing pulling on it. Actually, here go the tubes right here. Tubes ain't in it. One of them I busted. I dropped. Tram doctor's getting old. Right, busted up tube. So no tubes in it. I think we got maybe 1 extra or 2 laying around. Plus we got other amps. We got a Dentron we got 2 Dentrons, DTR is it, and I believe a Clipperton with 4 572Bs. We just did a Mohawk with 2 572Bs. So we got a few laying around. So we if we can't find an extra tube, we'll pull one out of one of the amps. So anyway, I don't know what we're up to here, about 75 volts, something like that. I believe on the Variac we're pulling 16 watts, which is about what we expected. The fan's starting to run. And over here, look like we're up to about 500 volts on the plate, right? No, that's not right. I'm looking at milliamps there. Where's the voltage? It's the bottom scale on the voltage there. Sorry. So I guess that's about 700 volts, something like that. So anyway, we're gonna dial it up some more. I guess that's about 90, 25 watts. And it looks like 1800 volts on the scale there. Everything's good, no fusses, no musses. And then we're just gonna go ahead and dial her up to full voltage. Pull it about 40 watts. And a lot of that loss is transformer, you know, power supply losses. It's not 100% even with no load, so you're gonna get a little loss. And then you're running a fan, so that's pulling a few watts too. And then over here at the voltage with my cracked meter, look like we're up to about 2500 volts. We're gonna put it on the plate current, we should be 0. We don't have tubes in it. And then over here to grid current is 0. That plate meter isn't zeroed, so we'll probably zero that later. And over here for the high voltage, so the high voltage looks good. Only pulling 40 watts or so, hanging in there. Got it dialed all the way up on the Variac. And last, since this one uses that 120 low voltage, we got it on the foot switch. Where's the relay at? Over here. We're going to key down my foot switch, and if the low voltage is working right, you can hear that relay kicking in. There is a little bit of a delay with this relay, almost like a SSB delay. But I guessing why they did that is because, again, they used the negative bias going to the tubes, also runs the relay. And let me shut this thing off. And what they do is they got the negative bias going to one side of the relay, and then the outside, the output side of the relay, if there is such a thing. Yeah, I guess so. Power on one side, the output side, or the negative. Well, I guess negative don't work when it's negative bias, but the positive side or the ground side goes to the tubes for the negative bias. So in standby, it's got the negative bias going to the tubes in standby, and through the relay. And then when you hit your foot switch, it grounds that ground side of the negative bias. Hence, it grounds the tubes, which is an interesting and weird way to do it. But they do that. Why would they do that? People ask me, why would an amplifier company do that? Cost. Because you can see that relay, it's the only relay in this amp. It's 2 legs. Input leg, output leg. That wire across connects to input and output during standby, and then when you key down, it goes to the coaxial out, right? The input and output. So they don't need a third leg to ground the negative bias or to disconnect something or to activate it, make the thing conduct, because again, they use the negative bias going through the relay and to the tubes, and then when you use the foot switch to ground the negative side or the positive, well, there you go again, the ground side of that negative bias coming through the relay. Since you're grounding the other side of the relay keys, and since you grounded that side of the negative bias that was going through the tubes are now grounded and activated instead of being in cutoff. So that's an interesting way to do it. I don't like negative bias, 120 volts going out to your foot switch. And if you're using like a radio to key up the amplifier, like a lot of modern transistor radios do, they have a output that keys up the amplifier. Most of them cannot handle that negative 120 volts negative bias. Most of them are made for a much lower voltage than that. So interesting way to do it. It works for the most part, but again, it won't work on certain radios, and it's a little bit, it's not 1000% safe. I use that one again because you got a negative 120 volts coming out through your foot switch. It's connected to the tubes too. So what happens, it's connected to the tube grid 1 of that triode. So what happens if that tube arcs, right, from the high voltage to the grid, which does happen. So now your high voltage has arced to that negative bias, which is connected to your foot switch, and if it was connected to your transceiver, your nice radio and all that, kaboom goes the radio. Okay, that's this one. That's it for this one. I'll go more details on it once I get it fully going. But that's my initial power up of the Heathkit SB-200 Ugly Betty.